Hello and welcome to our series of webinars on grazing management. My name is Rachel Dorney and I'm the local regional agricultural land care facilitator in the upper region of Northwest LLS. My co-chair is Lana Andrews, who is also a regional agricultural land care facilitator for the lower region of Northwest LLS. We will have a number of speakers in this series of webinars: Mark Gardner from Vanguard Business Services, Nick Henry from Cibolabs, and Brett Smith from Elders. We would like to show our respect and acknowledge the traditional custodians of the land of Elders past and present on which this meeting takes place today. The Maintaining Productivity in a Variable Climate is a series of workshops covering particular areas which influence productivity and profitability for an agricultural business. These webinars are the second workshop in the series focusing on grazing management. We've been impacted by COVID and have adapted to recording this workshop instead of face-to-face. This is a pilot to see if it is an alternative way to deliver this information to local producers. Any feedback would be appreciated. Where to from here? We will be running 3 30-minute drop-in discussions for anyone to ask questions of the presenters on the content. We would not be able to run these workshops without the support of our funding bodies: Northwest Local Land Services through the National Land Care Program, Federal Government, Cibolabs, and Meat and Livestock Australia. I'll now hand over to Mark.
Thank you, Rachel. That's a great intro and summary of where we're at. I'd like to introduce Nick Henry from Cibolabs, and we've been, along with Brett Smith and Nick's company, been running a producer demonstration site project up at Walgett, funded by Meat and Livestock Australia, where a couple of years ago, we started to load 3 case study farms into the Cibolabs technology. And we've been starting to work with the landholders over a period of time to see this technology in practice. Over the last 6 months, we've been meeting monthly to go through the figures and talk about what it means and the implications, and importantly, to develop confidence in matching what we see on the screen with what we see out in the paddock. It's been a wonderful learning experience, and we thank Gemma Hartog very much and Ian for volunteering their property as a case study for us today. So Nick, over to you, and can you lead us through the whole Cibolabs technology and how we can use this remote monitoring?
Yep, no worries. So first off, I'll just start sharing my screen, and I'll pull that in. There's some. I've got a bit of a slide deck sitting there as well, mainly as a backdrop. So Cibolabs, there's a lot of data analysis services that we provide, and the one that we're going to be looking at today is called the Pasturekey. Primarily, there are 2 components to the Pasturekey, and it's a satellite-driven service. And I'll just open up the web map component of the service that we provide. Now, this is what we call the Sentinel-2 driven service, and that's a European satellite. Its accuracy or resolution is 10-meter pixels, and this service can be provided to our customers every 5 days. And in some places, it can be up to every 2 or 3 days. So this particular web map here we have is like I was saying before, the web map component, and it's provided every 5 days. But the main thing to understand about this, about the service, these satellite services, that cloud cover impact these services quite easily. And so what we primarily do with the web map component is that we provide a 15-day rolling average or 15-day rolling integrated service. So some of the imagery in here will be mosaic together from the last 15 days. The numbers and those sorts of things that we provide in the map are also 15-day averages. The other component of the service is what we call the data folder, and we'll go into this in a little bit more detail near the end of my presentation. And where every time we have the opportunity to carry out an analysis on the farm, we store all that data in this folder. So, and we provide both these items as links, online links to the customer. So back to the web map. What we're looking at here is just the standard backdrop to the web map. There are other backdrops we can have, like the Google Hybrid or the Esri World Image. And these services, for example, their resolution is 0.5 meter or sub-meter resolution. But we find that the Sentinel-2 10-meter resolution is sufficient enough to give us paddock scale information. The reason why I'm showing you the display image first is our first port of call whenever we open up the web map to see whether we've got good coverage or whether we've received good coverage for the property. And this is a good example because we've already got some cloud cover impacts on the farm or on the service that we've recently analysed. So we analysed this one that we're looking at here is back to the 21st of July. And like I said, every 5 days we have an opportunity to analyse, and it takes some time to process and analyse the imagery when we get it. So there is a delay between when we produce or when we receive the imagery and when we can actually deliver something into this web map. So the web map itself and the data folder itself are consistent URLs. They don't change, so you can always visit those URLs, and all we're doing is changing the content. This first layer we're looking at is called the display layer, and like I said, we just use it to give us some idea of how much coverage we got. And if we zoom into some of these, you can sort of see that the 10-meter pixel resolution does give us an ability to see individual trees and individual landform impacts or changes, like these line work through here, probably to do with cropping and so forth. So a good resolution for paddock scale information. The other layer we produce from the satellite imagery is what we call fractional cover. Now, the idea around fractional cover is to give us a look at how growth phase or growth stage, or what growth phase the plants in the paddock are at. So we're primarily looking at pastures or, small orb type plants as well as pastures. There is some work in forage shrubs. So we have been sort of playing in that area as well. I can't comment too much on that. Phil Tickle might be able to comment on that a little bit more. So this particular layer, which we call fractional cover, looks at the growth stage of all the plants in each paddock, and you can sort of see the distribution in each paddock. So or in the paddocks themselves. And so what we're looking at here is a range from, say, a similar sort of like the barest or the bearing sort of parts of the property. You could sort of call them the emergence. In a growth stage, you could call that emergence. So in a cropping scenario, I believe this paddock here called sorghum is a cropping paddock. So it might be going through that emergence phase of a growth stage. And then as plants grow in this against this layer or against this analysis layer, we can see how they move from, say, emergence into actively growing, and that's the green part, or primarily actively growing pastures and plants, and then into the other phase of senescence and dying off. So we can see the full growth phase or growth stages of plants, which then gives us the ability to analyze the things like total standing dry matter or food on offer for that whole growth stage of that pasture type, rather than, say, only a limited version. So we're using the full spectrum of the Sentinel-2 service to deliver data at all growth stages of a plant's life cycle. And, you know, same sort of thing, we can look in here. So if Gemma was here, she'd be able to tell us what sort of pastures are growing in this paddock here, which are primarily senescing or drying off, going to seed. We can see in here that there's a crop probably starting to hit off. So I don't know what that crop is, but obviously we're picking that up. And you can see as part of through here that maybe there's been some rainfall, and some of these pastures in these paddocks are firing now. So we can sort of see impacts of environment or recent environmental or climate activities that have happened, like rainfall and weather and those sorts of things. And so we can sort of see how those sort of things impact plant growth. So that's the fractional cover, which is not around not around ground cover. It's just fractional cover, so how the plants are growing. And then if we move to the next layer, this is our total cover layer, which gives us a definite indication of how much ground cover there is. So in some cases, you might find that you know, an actively growing plant may have low ground cover, and a senescing dying off plant might have full ground cover. So they're not they don't sort of relate to each other. Well, they do relate to each other, but they don't. I can't remember the word actually. I'll remember it later. So that's the full cover, the full ground cover layer, which gives us an indication of how much ground cover we have, and we have the percentages here on the right hand side. And then the next layer is the total standing dry matter layer, and this is the layer that we use to support farmers in their decision making when they want to move cattle or a gist, or any of those sort of how they strategically move their livestock, cattle or sheep, however it goes. So this particular layer itself, so we're saying that back on the 21st of July, the pastures in these paddocks were producing a certain amount of kilograms per hectare, and these are our estimates based on a large set of calibration data that we place into a machine learning model that analyzes the satellite imagery on that 5 daily basis. So this paddock here called Woolshed Light. So and these ones over here, they're all Woolshed Light. They're one feature, multi-part one feature. We've analyzed the kilograms or estimated the kilograms per hectare for that, and we've calculated the total area of those 3 parcels. So you can sort of see with this Woodshed Light country that it's estimated to be around 2,000 kilos per hectare, and if we compare that to the black country, it's slightly lower in general terms. If we go and have a look at, say, a cropping paddock, you can see that they're lower, so they're probably in that growth phase, emergence phase, early growth phase. And then this one here, which seems to be running quite well, is over 2,000 kilos per hectare.
Lana, sorry, Nick. Lana, did you have a question?
I didn't have a question. We're just sort of at that 13-14 minute mark. So I was just going to ask if anyone else had any other questions or comments for Nick.
Nick, I think that's an awesome overview to move from getting into that sort of kilograms of dry matter a hectare. How does someone get their map into that system?
We usually negotiate with the landholder about what their parcels are or where their property is. So, for example, for Glenera and Somerset, they initially used one of our programs called the My Farm Key. I'll just pull that up, and basically it's a simplified application that helps farmers identify in a spatial context where their farms exist and what parcels relate, and so these are the legal bounds I don't have, I can use Glenella. That's my father-in-law's property. So we provide this framework in which a farmer or anyone working with a farmer can come in here and define in terms of the legal bounds, parcels, lot and DPs, where the farm is and the boundary of that. Now, with the Glenara Somerset example, we were provided by them the spatial layer for this. I don't have it here, so we'll just have to imagine that we started off with something that was shaped like this, had nothing to do with the paddocks, just basically the bounds. And then we brought that into our mapping systems and cut the paddocks based on what we could see in the satellite imagery, so the Esri imagery. We basically looked at the Esri imagery and cut paddocks out according to what we could see in the imagery. Now, after the initial phase of providing the service to them, we sent the paddocks to them, and they made suggestive changes to where the line work was, because we can only see so much in a satellite image. And then we also talked about this concept of splitting the paddocks into different types of land, so lighter land or dark land, landscape or even soils, so light soil and black soil. This one down here was more about splitting off the main cropping areas with the areas that could have some grazing capabilities. So we went through that phase with Gemma and the Hartogs to finalize the paddock map, and then we moved the paddock map into the Pasturekey service, and we were able to generate or give these bounds to the machine learning model, and it just starts running in the background. So it's a continuous process.
Thanks. And that process, whilst it might sound there's a lot of moving parts, was very easy, very, very easy. So it wasn't difficult at all to move a property into this mapping situation. So for anyone who's interested, definitely can contact Cibolabs, and it's not a difficult task to move from nothing into this situation. Yeah.
Well, the other options is that they can provide us with an already created layer, and that will streamline things a lot quicker than us having to map.
Yes, that's it. Okay, well, that might be the end of the first of the series. So thanks very much, Nick. And I think what we'll do then is call it quits on this one and start up again, delving even further into the information that we can get through this model. So thank you very much.
No worries. Thank you. Thanks for your time.